All right, so we're going to look at the second problem on the assignment that you had earlier this week. And in this problem, a spring is compressed 0.5 meters and has a spring constant of 100 newtons times meter, or newtons per meter. So calculate the amount of energy stored in the spring. Well, we know that the energy stored in the spring, energy elastic, is equal to 1/2. Not typing very well here. 1/2 times K, which is the spring constant, times the length or the stretch squared. And so I'm just writing that in. I am making it as an exponent. And so there's our formula, 1/2 kx squared. So to just go ahead and calculate that energy, it would be 1/2 times K, which is 100 newtons per meter, and then times x squared, which is meters squared. So 0.5 meters. And then that whole situation there has to be squared. And so I'm going to put it in parentheses and I'm going to square it. And so here we are. All right, so there's our formula. And so to do that, to solve that problem, is you've got to take the 0.5 and you've got to square it. And once you've done that, you have to multiply it times 100. And that ends up with 25. And then you have to multiply that times 1/2, or times 0.5. You end up with 12.5. And so I'm going to write that like this, that it gives me 12.5. And what was I actually looking for? I was looking for the amount of energy, so that's 12.5 joules. And so now I know the situation on that spring. Now it says a rock of 0.02 kilograms is placed on top of the compressed spring and the rock is launched to the air. Okay, how much elastic energy will be in the spring once the rock is launched? Well, this is really just a thought question. The spring is launching the rock off. The spring is, it was compressed, but now it's just going back to normal as it pushes that rock away into the air. So once the spring is back to normal and just sitting there, there's no compression. It's not storing any energy. So the spring now has 0 joules of energy in it. All right, so I'm going to write that down here, that the spring now has 0 joules of energy in it. I already explained it. So just going ahead and writing 0 joules. Whoops. 0 joules is the answer for that one. And then it says, how much gravitational potential energy will the rock have at its maximum height? Well, what happened to that energy that was in the spring? All right, it's not there anymore. It's got 0 joules in there now, but the rock is moving. All right, and the rock goes into the air, flies into the air, and at its maximum height, you know that it's not moving anymore because it's not going up and it's not coming down either. It's in between going up and coming down. And so it's actually stopped at the very height of its launch. So it has no kinetic energy. So where is the energy? Well, all of the energy now must be gravitational potential energy. It has 12.5 joules of gravitational potential energy at the top of its launch. All right, so again, you're thinking, what's happening to the energy that used to be in that spring? All right, then it says in the last question, it says you calculate the maximum height of the rock. Well, potential energy from gravity, gravitational potential energy, happens to equal mass times gravity, or the acceleration due to gravity, times the height. And so in this case, I'm going to rearrange that, and I'm going to get the potential energy, gravitational potential energy, then divide it by the mass, and divide it by gravity, and I'm going to be able to get the height. Okay, so potential energy is 12.5. The mass of the rock was 0.02 and gravity was 10. I'm going to let you guys solve that one just because I'm running out of time and I only have 10 seconds left. So you can solve for that problem. I'll give the answer in the worksheet for today.